The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We'll be doing our half-hour free training session today. With me, fresh off his holiday, is Kevin Rankel.
Hey, guys.
I guess it was everybody's holiday, so fresh off of everybody's holiday. Everyone's here today. I thought today we would start a series of training sessions where we'll start from the beginning of the part, and then we'll add toolpaths as we go along, and we'll see how far we get. And in the meantime, if there are any questions, please feel free to put your questions in the questions panel, any topics, any questions. What we can do is we can just do this as a kind of a base, but if there are questions that come along, maybe specifically on what we're doing, or if any questions that normally we would have covered in SolidCAM Live, let's do that. But as a base, we'll start from the beginning of this part. Not so much the beginning, because this is the same part we were looking at last week where the stock, the target, and the coordinate systems are already set up. I've just made a save and copy of this and eliminated the tools and the toolpath. So we'll start fresh from the adding of toolpaths. But in terms of the setup, this is the basic stuff. You can see there's a 3D model representing the stock. Obviously, our 3D model representing the target. So those are what I set up as the stock and the target. And then the coordinate system is basically just in the top corner there. If you want that to be reviewed, we can review that. But this is pretty basic stuff. And I think we've done a lot of these over the past couple of weeks that we've been doing SolidCAM Live. So any questions, please put them in the question panel. But Kevin and I will start by making suggestions on how to start with this. So Kevin, what do you think? Would we start on this with, let's say, 3D eye machining?
Well, I think first thing I would start off with is a vise. How are we going to be holding this part down? Just because that's going to determine what kind of toolpath we can use and how much stock do we have on the bottom, kind of per se.
Sure, yeah. We need a vise that we can hold that with then. Okay, so let's see what I got.
Well, Mark's pulling it up. The reason I mentioned that, and we probably mentioned this before in the live classes, but with eye machining and a lot of our toolpaths that are in there, it does have the full fixture detection and avoidance. So what Mark can do is put a fixture in here, and then when he goes to pick his toolpath, he doesn't have to worry about that vise being there. Now, majority of the time for you guys, you won't need to put a vise in there just because you guys know your machines better than any one of us. So you'll know with that material how much is sticking out, if we can get in that specific area, all that stuff.
Okay, so let me just see where I kept that vise from last time.
And the great joy of SolidCAM Live is I get to throw Mark with zingers.
Yeah, he's basically stumping me on my own setup here. Okay, so where is this file kept? On my other screen, open file location. Let's grab that one, put it over here. There it is. And we are looking for that assembly. There we go. Yeah, all right. Hopefully that is the right one. That should be able to hold it, I think. And hopefully if we make this guy flexible, we should be able to move those jaws. If not, we'll do what we can. Okay, so let's open that up. And let's see what we have in terms of mates. Distance mate and a distance mate. All right, I am going to get rid of that, or at least suppress that. And that should give me the ability to move that back and forth. Perfect. Okay, so kind of a review of pretty much everything we've done up until this point. So I've brought in a SolidWorks assembly that represents the vise I'd like to use. It's currently floating in space, and you can see that I've made it easy enough that I can open and close that. I'm going to mate this to my solid. So taking a look at it, I probably want to maybe hold it on maybe on this side and this side, because that is an open pocket there, and I'd like to take advantage of the openness there. So let's see, is there, yeah, okay, let's do that. So
Plus, that's how
I will go.
system is set up too.
Sorry?
Plus, that's exactly how your coordinate system is set up. So that Vise would be in the y-axis.
Yeah, that too. Okay, so let's go to mates. And let's start by making a width mate between that face and that face to this face of that stock and this face of that stock. You'll notice that I rotated it around because I have transparent stock. So if I try to click anywhere in here, it's going to think I'm going through that transparent stock and choosing the target face. But if I come over here, it now understands I'm probably trying to click on that transparent face there. So that is giving me my distance mate, or my width mate, but it kind of messes things up because they need to be more like that, which is fine, except that there is no definable distance between those two. So what I'm going to do now is I'm going to go to standard, coincidence, and we'll make that face coincident with that face. And now you can see that that locks it up there. So if I try and move this part a little bit like that, it's still going to stay sandwiched between those two. It's just going to move it up and down in the Z direction and maybe even the X direction. So we need to lock this in place again. So we'll go to advanced mates once again. And I like to use advanced mates not because I mean, when you're doing this sort of setting up of a vise, you want those two faces to be sandwiched between those as well. That makes sense because the vise is holding it there. But what it also does is it centers it. So if I want this piece to be centered in my vise, I could do the same sort of thing. I can say between this face and this face, I want the faces of the vise to sit. And now that's locked in the X direction as always being equal distance there. Now, again, this guy can only move up and down in Z. So now I'm going to set this up where I can go to standard mates and add a distance mate. And I'll basically say, I'd like to hold the bottom face of the stock down past that face by, let's say, 250. Let's see if 250 works. That's above the part, so I'll just say flip dimension. And now you can see that it's down by that much.
Now,
so
Brian had a good point as you're kind of still mating up. What Brian does with his setup is he'll just do his jaws only because that's the most common thing that you will run across, especially in a simplified 2.5D application here. If you guys start getting into 4-axis or simultaneous 5-axis, then definitely include everything in there. But yeah, it's a great point, Brian. Save up some assembly time and some component loading time as well.
Yep, absolutely. So that is a good point in terms of not using up too much time in terms of the assembly. But the fact that I have the entire Vise assembly here means that in the case of, let's say, a machine simulation, or in the case of 5-axis even more so, I can now set the bottom of my Vise as my fixture mounting position, like we talked about once before with the machine setup. And that's what I'll actually do here. But absolutely, if you're looking just for collision protection against the Vise, against your fixture, the only thing that's really going to collide is the jaws here. In the case of, let's say, maybe a drill or something like that, maybe I added enough clearance here. This is one of those things where when you set it up, you either set up the whole thing just so that you let the software take care of it, or you keep track of what you're doing and you know yourself what you're doing here, what spaces you have, distances, and that sort of thing. So there's always that same thing of you can skip a couple of steps if you just keep in mind what it is that you're skipping over, sort of thing. But absolutely, I would say just these guys here is all I need for fixture protection. But when I go to set this thing up in machine setup, I'm going to take advantage of the fact that I have the solid here and get the bottom center of this face to be my fixture mounting coordinate system. But let's see. Jake also has a question here. So can you show how to set up a second Mac or second position? Yeah, we could do that as well. So while we're here, let's set that up, and we can also talk about display states at the same time. So on this part, there actually already is a Mac 2. Because again, this is a copy from a previous part. So if we take a look at our Mac 2, that is, from the looks of it, the bottom corner of that part on that side. So we've already got our Mac 2. We just need a coordinates or a fixture for that second side. So I believe we covered this previously, but the way we would do that is, since I set this up as a separate assembly, I'll hold the control key, grab that, and bring it over, and now I have a second copy. Second copy that should have its own looseness there. It's floating. I can assign this for my second side. So what I'll do is I'll just do that. So if we want to basically hold it, maybe in this case, we have to hold it a little differently, I guess, because once we machine this, we're not going to have that same space there. So what would you say, Kevin? Maybe hold it on these spaces?
I would do the same way as you got it.
Yeah.
But just against the actual, because all we're really going to be doing on that backside is facing it off and then just doing a light cut. Yeah. So I would still say we're fine to cut it. And
I guess we have enough space on this side and this side to hold it. Yeah, okay. Okay, so let's do that then. So in terms of the mates, basically the exact same thing. So I'll click on mate, and let's do a advanced mate. Okay, but like Kevin said, we'll do it on these faces. So that face and that face, sandwiched between that face and that face. So we get the same sort of thing. They're trying to be equidistant. The fact that this thing is still floating means that, let me just click green check mark on that, means that when I close this up, it stays centered there, but I actually want that to be closed on top, so I can put a coincidence there. But before I do that, let me go back to that mate and take a look at something that is a common issue. No, that's under this one. Under its own mates. Let's see, where is it over here? It's over here. So that width mate that I just did, let's go and edit that. We're intending this to be on the second side, but it looks like the vise is still sitting basically the same way. What you can do is just click on this icon here, and it flips it around. So now the vise is facing downwards, which is what I'm looking for, because I'm looking to do this on side 2. So that's what I want. Okay, let's grab this guy and move it up here so things start to make a little more sense. And like we saw previously, we need to make one of these coincident. So I'm going to grab that face and make it coincident with that. So now that I've told it where I want that to sit relative to that face, you can see the width mate centers that up as well. So that thing is now centered. So we just got to do basically the exact same thing we did. So let's continue with that. So let's go width, and we'll say sandwiching that face and that face. So that lines that up in that direction. And then finally, how we're going to hold this thing. So we can do a distance mate. It's just going to be facing the bottom face there. So what I can do is I can just set it up so that there's some clearance. So I can say from that face to this face right here, we can set it so that there is, let's say, maybe ½ inch. That should give us enough clearance for if there's a ball mill or anything like that, or whatever I want to do there. And that looks like it's holding enough. Now, obviously, I can always shift that if I want to. I'm just going to set this as is because the numbers are. I need to hide if I'm going to basically work on this. This is going to get annoying if I have to keep kind of shifting it around. So what we can do is we can go to this icon here, the configuration manager. And what I'll do is just right click and say add display state. So this display state, if I highlight it and hit F2 on my keyboard, I can call this side 2. If I click on this one, hit F2 on my keyboard, I can call this one side 1. The way display state can show whatever solids on screen I want, and then with the double click, I can just go back and forth to different solids. So for instance, we are now, so let me hide all the side 1 solids. In that case, it's this guy right here. I'll just do all my side 2 functionality, my Mac 2 and all that. If I go back to my display state and double click on side 1, it shows everything again. Now I can go to the feature tree and hide the side 2 assemblies. There is my Vise setup for side 2. So go back to my display state. Now all I have to do to go back and forth between the two is just double click. Now in this case it was pretty easy because we only had one assembly. We had to right click and hide, but with a single double click I'm going back and forth between the two. You can imagine that if you had multiple setups and multiple solids, maybe not one full assembly, but maybe you have different solids that represent stock, clamps, different clamps all over the place, different solids. You could have a whole feature tree full of different solids you have to hide and show. But if you do it like this, it's just a single double click to hide and show a group of solids. So it makes it really easy to go between side 1 and side 2. I'll click on the save icon because everything I've done is on the SolidWorks side of things. So I want that to be saved in the SolidWorks side of the SolidCAM file. Now I can go back to SolidCAM and we can take a look at my setup for Mac 1. Right now, fixture says none. I'll go in there, click on the 3 dots, and now I'm going to set up my fixture for side 1, and that simply is just choosing the solids. And again, I could take advantage of our integration inside SolidWorks by clicking on CAD selection, and then instead of choosing the individual solids, I'll go to the feature tree once again and just say this single assembly represents everything, and it'll auto-select everything in that assembly as my fixture. In this case, the 3 solids. Now, if that is all I wanted to do for collision detection, that's good. But if I want to make sure that I tell SolidCAM where this is sitting relative to my machine 0, my table 0, I want to add in my fixture mounting coordinate system and my part mounting coordinate system. So let's do that real quick. So fixture mounting coordinate system is where your fixture sits relative to your machine 0. Basically, really easy. We're just going to set it up as if it's a coordinate system. So I'm going to say, for now, I'll just do top center of model box, only because I'm about to choose this bottom face, and I just want to get the top center of that face. But obviously, the coordinate system is facing the wrong direction. I need Z to point upwards, and I probably want X to point in the proper direction. So that's just basically this guy right here. We'll do a flip. Z is pointing in the correct direction. Flip around Z to get X pointing in a similar direction to Mac 1 position 1. And that's just my
headset
fixture mounted coordinates. No, no problem. Nobody noticed you were gone. No, we always miss Kevin.
While Merck is doing this, this isn't, now kind of going back to the same terms like what Brian was talking about, just setting it up simple and easy to get going. This is definitely something that is not 100% necessary.
Yes.
This is just, if we had a high-end part and we had the extra, probably 2 minutes that it would take, because that way Mark wouldn't have to explain everything, then you guys can set it up that way. But if you guys are in a rush, there's no need for the fixtures or the putting the setup for the fixtures in there.
Yeah. So part mounting coordinate system is just recreating Mac 1 position 1. The purpose of this is to tell SolidCAM where the part is sitting relative to that coordinate system we just created on the fixture. And basically, you're going to just create it the same way. So top corner model box, I'll click on the top face of that stock. And it's in the wrong position. I'll just say pick origin, move it over there, and that's it. It's exactly where Mac 1 position 1 is. So it's like Kevin said, this is not necessary. What this will do, however, is if you need your machine setup to be accurate, by doing it this way, when we look at our machine preview, everything is going to sit correctly now. There's no need to modify, if necessary, for things like 5-axis or your machine sim. These can all stay at 0, because now these are basically how far away the coordinate system is sitting from the machine 0. But since I did all those coordinate systems just now, everything sits correctly in the machine preview once it pops up. Okay, so there's my table 0, my Mac 1, all of that is sitting correctly. The fixture mounting coordinate system is over top of that. If I come over here and let's just do an example of how far away the fixture needs to sit from the table, let's say for whatever reason there's a spacer there, that represents that distance there. So this is the machine 0. If you had a machine sim, this would represent your table. And you can tell where your fixture is sitting relative to that. In this case, let's say a little more realistic example is maybe I don't have the fixture sitting exactly on 0. Maybe it's on the table, but maybe 10 inches away from that corner or something like that. So this is the way to actually get these exact numbers. So it makes it real easy to locate your fixture in your machine sim. So, but again, not so much necessary if you're just doing simple 3-axis stuff and you're not doing anything with the machine sim, you don't even have machine sim, or you don't have a pivot point you have to define for your 5-axis. If you just need to get going, you can easily skip this. All you really need to do is just assign those solids as your fixture, and you'll get the same fixture collision protection in your 3D toolpath that you would get as I'm doing here. But everything ends up being the same. It's just you're skipping a couple of steps. Okay, let's just do a save on that as well, because we did make some changes to definitions, like display states. We'll just say yes to that. So now all the definitions are in place. We can add some toolpaths. So what do you think, Kevin? What's the first thing you would do to this part?
Do we have material up on the top?
Let's double check. Yep, we have a machine, and looks like we have some default aluminum defined here. But yes, we do have material.
Okay. No, I meant like excess material on the top, or are we right up to
Oh, I don't know. This is the default part, so I don't know what they did here. Probably not that much, if at all.
It looks
Yeah,
like
there's
we're
nothing
right
there.
Okay. So I get, you know, as Mark and I go through this part with you guys, you will see, you know, just like machine, there's more than one way to skin a cat. So I may do it a little bit different than what Mark does, and we may do it different than how you guys would. So we're just going to kind of show you how maybe Mark and I would approach this part. But me personally, I would start off with a 3D machine.
I would as well, especially even if there's material on the top. You notice that at the end, this thing's not going to have any top face there anyway. So there really is no point in wasting time going back and forth and facing that when we can probably just finish those rib tops later with like a profile or something like that. So I wouldn't waste time removing any material that's just going to be roughed out anyway. So 3D machining would be the thing I start with. And then, you know, in your 3D machining, you can put a floor offset. It'll leave the amount of material you're looking for on the top there anyway for that final finishing with a profile or a pocket or whatever. But the irregular shape of this part makes me think I want to do 3D machining. There's a couple of pockets there. I can choose them individually in, let's say, a 2D machining with the pocket recognition. But there's some tapers as well. Maybe there's an outside edge there. And if I have access to 3D machining, it will be the first thing I do. It's the most powerful toolpath. It takes care of everything. I would just do that. But in terms of strategy, if you don't have 3D machining, look at one of your 3D toolpaths. Look at HSR. Maybe look at the pocket recognition toolpath. If most of these are pockets, you can use pocket recognition. And if you only have the 2.5D package, then you can still do this with the pocket toolpath. You can use the smart face option, so you can just click on the bottom face of each of those pockets and it'll recognize the geometry for you. That should give you somewhat of a shortcut. But any kind of recognition toolpath, any kind of automatic selection toolpath, that's going to be your benefit when you have a part that has multiple features like this.
And I'm actually going to take you one step backwards, Mark, and give you a little explanation of, and maybe we won't even get to putting on toolpath today, but on a particular part like this, when I would be out on the shop floor machining this part out, what I would do, so for Mark's stock, he's got it up to size right now. And what I would actually do is add an additional 10 thou of stock on there, just for the model. Now, when I go to cut it on the saw, I would cut it right up to my exact size. But then what I would do, instead of putting the coordinate system in the top left, I would put it right in the center. And the reason why for that is maybe towards the front of my part we're right on size, but maybe my saw blade is getting dull on me or something like that. So we have a little bit of a draft. Well, what that will do is by probing up or putting that coordinate system in the center, it accommodates for any extra material in a way. So it's finding the exact center. So let's, if Mark, can I get your keyboard real quick, Mark?
Yeah,
I'm trying to point at stuff and I can't. Okay.
Go ahead.
So what I'm getting at, guys, is let's say, you know, right over here, our dimension is right at, 11 inches, but maybe over here, we may be at 11.25 inches, which isn't huge, but the software is not calculating into factor that there's an extra 1/4 inch over here. So like I said, what I'll do is I would put that coordinate system in the center, and then using the probing software, I would find that center position that way, because that way, if I have a little bit extra material down here and smaller over here, and then over here, it's with the probe, it's going to automatically put that right in our center of our stock. So if we're just a little bit out of sync a little bit, that way it kind of corrects everything. Does that make sense?
Yeah, I mean, everything looks ideal and nominal inside the software, but absolutely anything you can do on the actual practical side of things to make things a little more easier to account for that imperfection. That's obviously, yeah. The way I was always trained was that, but I think it's because the guys in that shop, they got some nicely cut pieces of material. But yeah, definitely, anytime you're trying to deal with that imperfection of your stock, that's a good way to do it. There's a question there from Clinton. So is there a way to adjust the lead-in distance on an iMachining toolpath? XY clearance on a stock model when it is plunging moves from clearance. The lead-in distance, is there a new functionality for that, Kevin? I can't remember.
Yeah, you can change are you talking like the arcing distance, or like how much it comes off of the floor, Clinton? The arcing. Okay, that would be in the technology or the link page. And if Mark switches it over to, well, yeah, go to, I'm trying to think, if we switch it just to instead of multi-tool right now, just switch it to iFinish. And then under the technology page, we have what's called large lead in and lead out move. And this way, and the reason I had Mark switch over iFinish, because it will show everything that is here. So, we can do a lead in and lead out at the start of a chain, which there's a checkbox for. There is a large lead in, lead out checkbox as well. But the actual physical numbers of being able to type that in there is none in there. The only thing that you can modify is the as it's moving along. So as it arcs into a corner, it slowly starts lifting off to reposition itself to start cutting again. By default, that is 3 thou. Now, if that's something more that you would want in there, you can change that. So to answer your question, yes and no, Clinton. You can't physically type a number in there, but you do have the ability to make that larger or smaller. So I don't know, Mark, but we are kind of getting towards our end of our time here. I think maybe tomorrow what we'll do, at least this way, we got the Vises set up for you guys. We have the stock set up, the coordinate system set up. And then maybe tomorrow we will start off with, as both Mark and I agreed that, starting off with 3D iMachining, but I think we should go one step further and let's probe up our part. So we'll maybe tomorrow we can show you guys how to probe up that part, and then we'll start doing the 3D iMachining.
Yeah. So we'll start this as a series of SolidCAM Live videos where we're gonna go from beginning to end. So today we did the setup. Tomorrow we'll do the probing, and we'll see how far we get with Toolpaths. So that will be tomorrow at 2 p.m. Eastern time. Up until the end of June, we're gonna continue these. If you have any questions you'd like addressed in the meantime, we'll continue with this series of this one part, but we're always ready to answer other questions you get, kind of like we did today with the questions we got from everybody today. So you can use my email. Kevin's going to put my email in the chat section, and you can use my email, and we will answer any questions that come along in the meantime, but we'll continue with this one part. We'll apply Toolpaths. And as always, like I always say, if you know anybody that can benefit from SolidCAM, please give us their contact info or get them in touch with us. Just contact your local salesperson, get them in contact with them, and you are entitled to a finder's fee. I believe it is still the $100 Visa gift card just for getting them into a demo. It is a certain percentage. I believe Kevin showed us that flyer
20%.
last time,
Yep.
20%. 20% if it goes to sale. So if there is a sale, you get 20% of that sale. And that is really good. So anybody you know that can benefit from SolidCAM, put them in contact with us. We will continue this, like I said, every day at 2 p.m. For now, stay safe, keep your family safe, keep busy. We will talk tomorrow. Have a good day.
All right, see you guys.